All right, here's our unit circle, and I'm going to explain how to fill it in 5 minutes or less. So I'm going to start with the explanation, and then I'm actually going to do it in 5 minutes or less. Okay. In the center circles here, and this is a tiny version, we're going to put the degrees. And the way I do it is that if I add as I go around the circle. So your mental math skills are going to really help you on filling this in quickly. The large space is 30 degrees, and then the small space here measures 15 degrees. So for the large space, we're going to add 30, and for the small space, we're going to add 15, and that's how we're going to go all the way around. And that should take less than a minute. The next easiest thing are the coordinate points, but we'll do the radians next. The radians to go all the way around is 2 pi. So from there, it's just a bunch of fractions, a bunch of slices. So 2 pi divided in half is pi. And then what we kind of do is we see every angle as a fraction over 180 in degrees. So 30 over 180 is 1/6. So that would be 1/6 of pi, since pi will be equal to 180. The coordinate points we do by just counting 1, 2, 3, 1, 2, 3, all over 2, square root on the top. And then we reflect those points to their reference angles in the other quadrants, with quadrant 1 being positive, positive, quadrant 2 negative, positive, quadrant 3 negative, negative, and quadrant 4 positive, negative. Okay, are you ready? I'm going to set the timer. So I hope I can get this in one shot. And we're going to start with the degrees. Are we ready? Get set. This is 0 degrees. We're going to add 30. Then we're going to add 15, add 15, add 30, add 30, add 15, add 15, add 30. Doing okay? We're going to add 30 degrees, add 15, add 15, add 30, add 30, add 15, add 15, and then 0 is equal to 360. So that took 38 seconds. So now let's go on to the radians. So this is 0, but all the way around is also 2 pi. So halfway around is pi, and this is pi divided by 2. Down here is 3 pi over 2, because it's 1.5 pi. Now 30 is 1/6 of 180, sorry for the band-aid. So this is going to be pi over 6. Now I'm going to jump to 60. 60 is twice that. So that's 2 pi over 6. 2 pi over 6 is pi over 3. So 1 over 6, 2 over 6, 3 over 6, 4 over 6 reduces. 5 pi over 6. 6 over 6. 7 over 6. 8 over 6 reduces. Down here is 9 over 6. 10 over 6 reduces. 11 over 6. That's how I do the 30s and 60 degrees. Now 45 degrees is 1/4 of 180, so this is going to be pi over 4. 2 pi over 4 is 90 degrees, so this would be 3 pi over 4. 4 pi over 4. 5 pi over 4. 6 pi over 4. 7 pi over 4. 8 pi over 4 is 2 pi. Those are our radians. Done. Now it's a unit circle, so the x value here is 1 and the y value is 0, and the x value here is 0, the y value is 1. X is -1, y value is 0. Do not get these confused. Please make sure those are right. And now we're going to count. 1, 2, 3, 1, 2, 3. All over 2, all over 2. Square root's on the top, square root's on the top. What's the square root of 1? What's the square root of 1? It's 1. Oops, did I miss this one? Okay. Now we got to think of the reference angles. We don't want to do any crisscrossing. We want it to reflect. So pi over 3 will go to 2 pi over 3, and that's going to be -1/2, negative square root 2 over 2, negative square root 3 over. Okay, I didn't cheat. I had to pause the video because the lights came off. So we got the x values are negative, and then the y values match 1/2 square root 2 over 2 square root 3 over 3. Okay, we ready to go to quadrant 3? I'm going to restart my timer. Now, do you see how this is 5 pi over 6? That's going to match with 7 pi over 6. The same x value because they're at the same place. Okay, here I go explaining when we're supposed to be doing it quickly. Now, what about the y value down here in quadrant 3? The y value is going to be negative now. So negative root 2 over 2, negative root 2 over 2. Do you notice that at the quarters, at the 5 pi over 4 reference angles, we have the same, look at me explaining when I just need to be going. You notice that these are the same x and y. Okay, so to go over here, make sure your pi over 3 matches pi over 3 here, but the x value will be positive 1/2 and the y value will be negative. Positive x value, negative y value, positive x value, negative y value. Okay, so with some explanation, that was my time, 4 minutes and 23 seconds. Not bad, not bad. How do you check it? The reference angles, again, you guys, is so important. That's why we started with those. Pi over 6, 11 pi over 6, 7 pi over 6, and 5 pi over 6. Do you see how that makes a rectangle? Yeah? Do your rectangles all have the same values in the correct spot? Are all the x values the same and the y values the same? And are the positives and negatives correct? So to help your x, your unit circle out, let's make this positive positive. Quadrant 2 would be negative positive. Quadrant 3 would be negative negative. And quadrant 4 is positive negative. And let's review what the values are on the unit circle. So this is only for the unit circle when radius is 1. R equals 1. So the sine is going to be equal to the y value, the cosine the x value. The tangent is sine over cosine, so that's y over x. Sine theta over cosine theta. And the cosecant is the reciprocal of sine. So that's 1 over y, or just the reciprocal of y. Secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. So that would be x over y, or cosine over sine. That's how you fill in the unit circle in less than 5 minutes. Again, this is a memorization. It's not a where these values came from. It's not a proof. So there's lots of videos on that you can look up. That's just how to fill it in quickly so you can evaluate and answer trig functions here. Thanks for watching.